All right, good morning, good afternoon. We'd like to thank everyone for joining us. My name is Dave Howell. I'm the CMO at Legit Security. I'm joined by Liav Caspi, who's our co-founder and CTO. And today, Liav is going to talk through the topic of AI-generated code and the next era of secure development. So we're looking forward to this conversation. If you have any questions as we go through the webcast, feel free to drop them to the chat, and we are happy to. And I will kick it over to you, Liav.
Thanks, Dave. Welcome, everyone. In the next 30 to 45 minutes, we're going to go through some of the insights and data that we have in Legit about AI-generated code, and then the risks in this new generation of secure development. The agenda for that particular webinar is going to be it's going to be a talk between me and Dave, but basically we're going to go over the changes of what happened, and then and this is, I think, the area we'll spend most of the time. What are the risks of vibe coding or AI writing code? And then also we'll touch on how application architecture is changing. We'll do a quick demo of some things that Legit did today and summarize. And then obviously this webcast is recorded. You can watch that, and we'll provide information how you can reach us at the end. Dave, stop me if I missed anything.
We're good so far.
Let's dive right in. So I guess everybody living on the planet and is engaged in code at somewhere or another, either from a security or from an engineering perspective, knows that code generation by AI is something that has taken over completely engineering. Google has this nice counter that they share of how much of their code is written by AI. They actually count characters or lines of code. And very recently, they published that they passed the 50%, which means that basically most of their code, or the 0 to 1 version of their code, so the anything that starts new software, updates, bug fixes, features, starts by AI. Obviously, they're human in the loop, but they come at the second stage. The second piece of evidence is that the two fastest growing companies today in the world are both vibe coding companies. One is Cursor, an IDE for generating code. So it is just one product among a family of solutions that I'll call in this webcast coding agents, but they are basically AIs that write your code. And Lovable, which is another product that lets you spin off complete applications just from English prompts. So you can write, I'd love to create maybe a car renting application, and then it will just spin up a complete app with database, with a backend, with a front end in minutes. These two are now the fastest growing company, which means that this is a huge change is happening. We're just at least per our forecast at the beginning of the change, but it has a lot of implication on software and also on software security.
Hey, Liav, let me ask you a quick question here. So when you look at that growth in Google's code that was written by AI over the past, let's call it 18 months, that level of increase is rather impressive. Do you think that kind of growth is sustainable? And what would you anticipate we'd see over the next 18 to 24 months?
I think it will grow to be, again, you could argue what is the method of counting, but ultimately I think AI would be involved in code generation in 100%. So anybody that is going to create new software or going to do an engineering task, instead of opening an IDE and start typing code, the joke is would press the tab button or basically use the agent to do the first attempt and then would engage in coding. So I think AI would be the first step of code generation in close to 100% of the cases. And if not, it will be very heavily involved. So it will review the code, look at it, alter it. It will be heavily involved in 100% of the cases where software is written.
Thank you.
So I want to call out three changes on what's happening with AI. One is basically we say AI is building software. So instead of developers writing the code, AI is building that first version of the code. The second thing is, and this is something we will discuss during that presentation, is that AI brings new software architecture. I like one of the presentation by Andrei Karpathy that called this called Model Software 2.0. But basically, if you look at regular code as traditional software, and you look at AI as a modern component of software, sort of like a black box or a white box where you could neural network where you can interact with and ask to process information or even look at an agentic system that can perform tasks. This grows inside a software portfolio of companies. It becomes part of the architecture of every software, and every organization I'm speaking with on the software they're building admits that they can introduce AI into almost any software they have to make it work better, whether it's analytics or user interface, or AI is something like electricity or a superpower, something that you infuse into your software that can perform tasks in a better way at certain use cases. But what it brings is that the architecture of software changed. Lastly, is that AI enables, and we'll talk here, things in secure coding that weren't possible before. So if you aim the AI technology correctly at the task of not just write software, but write secure software or fix problems in insecure software, then it can solve a lot of the things that are hard for people or just are very time consuming for people to do. And these are three things that are now happening in secure development. The other way I like to think about it is that I think the way of developing has changed, and we don't fully know where it's gonna end. AI writes code, it's doing it via different entry points. So it might be directly in the IDE, but it might also just spin up a complete application on the cloud. So there's different interaction points to the traditional CI/CD. What's also happening is that design phase becomes critical, because instead of writing code and the actual building of the code has the logic, now you're investing more in the instructions, investing more in what is the design of the software, because AI is going to just build what I want, but I need to articulate very well what I want, which has been the case in agile work. In agile work, you're describing something very small incremental step, and you keep incrementing. Now you have the opportunity, okay, I need to describe that step. I need to describe my overall design. It shifts the spotlight into different areas of the traditional software development lifecycle. And then I wrote here something about AppSec, but I really believe that AppSec tools used to, or still today, their output was a list, was a report. This is most of the products today to do security, and in a report of finding. I think today, because of AI, certain bottlenecks have been removed, and now an AppSec product is not just expected to end its work by providing a report. It's expected to do something. It's expected to, the expected artifact is, hey, I fixed it, or I automated the fixing of it. So I think this is also a change both in the expectation and technology because of these bottlenecks that were removed. If you look at development styles and the technology that supported it in the past, we started with waterfall, which in the past, on-prem systems, technologies like Subversion, we were running pen tests against software, long iterative steps. Moved to Agile, where we started using Git and Jira, and then Agile very fast transformed into what I think was the reality, I'd say 2 years ago, which is cloud-native development, CI/CD. A lot of Git operations, using SaaS services for building your code and storing it. The whole practice of DevSecOps, the whole practice of security guardrails baked into the process. So I think we're now in transitioning from the cloud native CI/CD pipelines into the area of Gen AI development. We know it has vibe coding tools, which are must-have tools for any developer, something like Cursor, but we don't really know what is the entire tech stack there. What is the security tech stack for that area? Do we have all the deployment tools covered? I think the industry is still trying to figure out what is this Gen AI pipeline looks like. And we don't know where we're going to end up. So if you look at a traditional CI/CD, the cloud native CI/CD, you've got all those security tools like SAST, SCA, DAST running periodically or running before code merge at various points, sometimes during build. This is the standard. What is this AI native pipeline? You've got things that go directly from design to deployment and bypass the entire chain. You've got AI models with their different code components that needs to be trained and updated and be also introduced in the process. So it's not just code that you're building in. The builder is not a human. So there is sometimes situations where there's more and more steps that's required. So this is today, the way I see it is a question mark in industry. The opportunities and the prediction that I have is that eventually security has to be both that generation and also automatic. And I think during the presentation, I'll also explain why. So I want to talk about some of the security challenges of this change. Challenge number one is there's a lot more code that's being written, but there's less oversight and less governance. So the capacity of people to review the amount of new code that's created basically stayed the same, or even was reduced. So if the end result is to move faster, then something has to change to make the equation balanced. So it's either the code is not governed, or we need to introduce more automations and ensure that everything is still being checked. The second challenge is that the coding agents are risky. It's been proven time and time again in every test and every risk and a lot of news events are coming out. We'll speak about them, that coding agent, coding assistants have many risks associated with them. They're basically collaboration tools that went to the market very fast to provide value, but when adopted in masses, in large scale, thousands of developers, they have many security risks, and we're starting to uncover them almost on a weekly basis. The third challenge is that any AI-based application that we're building, we're starting to bake in models, it's very challenging to secure. We're basically using prompts for any form of instruction or communication. It is very, very unpredictable. So we might expect an application to constantly do the same thing all over again, but it doesn't. And there are many risks associated with the architecture of AI-based apps.
Liav, one question here. You used the word governed and governance when you started with security challenge number one. That's a pretty broad term, particularly in the security market. Can you just double click on what you mean by governance in the context of AI-generated code?
Yeah. So there's two things that, at least when we talked also to our customers, that we hear. One is be in control of what's happening, which means what tools are generating code, what third parties are they interacting with. So where is your information? Who is your information being shared with, and where and how and what information? So being in control of making sure that you know what people use, because the influx, the amount of tools that exist today and opportunities is huge. Developers are tempted to click through and install something, and then inadvertently, sometimes it's not even a malicious component, but their code is used to train models. Their secrets are sent to a third party. So it opens up the way for many, many risks, and especially in large organizations which are regulated and have to ultimately be audited for specific standards and dealing with sensitive or financial data. Making sure your environment has only the safest or tools as deemed is one. The second thing is to make sure that the actual code itself that's being generated by AI gets treated at least in the same level you will treat a human code, it should be treated usually with a lot more doubt and suspicion, because as we'll see in a couple of slides, this is not a secure code. And so it makes, so the second aspect of governance is to make sure AI generated code has a consistent flow in the pipeline that guarantees it goes through security gates that prevent some of the risks that are imminent. Cool. So with every risk, there's opportunities. So what are some of the opportunities that we have with this AI technology? One is let's move even more to the left. So we have an opportunity as we build this new AI coder, the coding agent, to make it a secure developer. So we can shift the traditional security guardrails to the generation step and improve the level of security of the coding agent. It's a complete analogy as though it were a person. Imagine this coding agent is a developer. The question is, how can we make this developer create much more secure code? Can we train it to do much more secure code? Can we give it instructions? Can we scan the code and give it feedback during the code generation process? All of the answer to all of these is yes. It is very possible, and it's a massive opportunity. The second thing is let's put safety guardrails on vibe coding. So it's the analogy is let's put a seatbelt in this new fast car that we have. There are many protective measures that you can do to make sure that as you generate your code, you're not falling off the cliff or doing something that's dangerous. So hardening the tool set, ensuring you're using safe third parties. I'll show some example later on, but ultimately, these are settings and configurations, architectures that are possible today. So it is possible today for an organization to think about how can we put those safety guardrails and make sure our developers can move fast, but securely. The third opportunity is let's build a secure AI architecture. Let's find those flaws in the architecture, point AI to help find them, and make sure we release AI applications in a secure way. There is technology that exists, and us in Legit Security deal with all three opportunities that can help you do all of them and ultimately increase the pace of development, but retain the level of security you have.
So when you're talking to customers and prospects and the topic of vibe coding comes up, I'm curious as to where they sit today. Is this something that they're thinking about generally, beginning to experiment with, considering usage of at enterprise scale? And I'll add to that, when we were at Black Hat just a couple of weeks ago, I was pleasantly surprised with how familiar and interested booth visitors were with what we could do around vibe coding. But what do you see in terms of the conversations you're having?
The common theme that we see is that organizations, especially large ones, there's a CEO or executive level order inside a company, thou shall AI. So please use AI to generate, to develop, and there's an increasing pressure, especially in engineering teams, to adopt AI tool because everybody has a FOMO of there's this new cool tool around. We have to use it. So this is what's happening at engineering. And then when we speak with security people, usually they convey a lack of control. Like we don't know what developers are doing. We are constantly hearing about all those sort of risks. We're also being asked to do this and move very fast. So the two things we hear is lack of control and pressure to move very, very fast on these projects. So I think and as we showed, it all begins with this governance thing we talked before. Like, how do we even start to understand what's happening in the company? What are developers using? and help them standardize and secure the tool set that they're using. Cool. Cool. So let's start talking about now for a few minutes about why vibe coding or code generation is a risky business. So there's a couple of researchers. I quoted here one of their codes and one from, I think it's from one of the university. Both found large number of security risks in code. One said that 20 to 30% of snippets had some security problems. And then recently, this report here actually is pretty fascinating because it says coding agents choose an insecure option. So it means that they're not really, in 45% of the time, they're choosing a more effective way of writing code and not the secure way, which you could say makes sense. The whole goal and the whole benchmark of secure agents is to get something working out of the gate as fast as possible. They haven't been trained for secure code. It's not part of the incentive of the coding language model today. And the blue line that shows syntax has greatly improved over the last year. So the code is becoming more correct, but the security has not. So as it implies, again, this is just an assumption, that as models become better, they are now focusing on making the code be more accurate and pass a syntax test, and not focusing on training on security. And again, this is, I don't know if this will stay like this, but the current state of things is that something between 30 to 50% of the code that's generated has security flaws, which is an alarming number. It's basically said you can't really trust any code that's coming out of the coding agent to be secure code. Even, I didn't put here, but every time it's also compared to what a person is doing, it's usually more insecure. I wanted to share with you, I'll go very quickly about a list that we've done internally in Legit that shows what are all the risks in vibe coding, and then I'll share some examples, because they're starting to mount up, and we're starting to see more and more and more cases and attacks and attack vectors and risks associated with the practice of, again, calling here vibe coding of AI code generation. So insecure code generation, obviously, like creating an insecure code that actually, encrypts in an insecure way, or uses an external variable, creates an injection attack. This happens frequently. Code exposure is a second risk. The AI basically can send your code to, or train on the actual source code that's there if it's not correctly configured. Harmful agent operation. I don't know how many of you are familiar with the cursor YOLO mode that used to be, but basically the agent can deploy. It runs Git commands, it does database migrations. It could very easily delete certain important things or do harmful operations. YOLO mode and cursor was like, I trust the agent to run any command they want. So there was a switch for developers to say, I just want the AI to do whatever they want. And then the AI basically started deleting code, copying code, or doing things that ultimately could be harmful, sometimes even irreversible. Bypass of security controls. So if you're developing in a tool like Lovable and deploying straight to the cloud, you won't go through the actual CI/CD pipeline. You won't be scanned by a SaaS tool. So vibe coding allows developers in many cases skip the tests. Data exposure by MCP, we'll talk about this as well, but MCP plugins can take your data and you have no idea what they're going to do with it. Supply chain attack via agent prompt injection. This is actually a vulnerability that Legit found, where we could have put a prompt injection into the agent to basically write any code we want. So we could have hidden an instruction, and the agent would introduce something malicious into the code, or some functionality that we want, introduce a library. So again, very possible. Agent instruction poisoning, similar attack. You could just lay out a file with agent instructions. Developers might want to find it, and the agent will do things that might be malicious or harmful or create bugs. Hallucinated library injection. This one also, I've got one slide about this, but AI tends to invent library names And some attackers thought, what if we could just create a library that's constantly being hallucinated, and people would just download it and use it, and eventually will compromise them. So it is a real thing that happened. Secret exposure by agent love secrets. You know how many times I used the tab key to autocomplete, and it basically auto-completed some hard-coded password from somewhere in the code base. So the agent is learning about the hard-coded secrets that you're putting, auto-completes them for other people, put them in various places in the source code. And then last one is untested Gen AI code. So it's basically, we just don't test it. We don't run any scan on that code. We know it's going to be a bad code. We don't test it, and this code goes to production, and it's a game ball. If you want that list or drill down, I'll feel free to share more information if you contact us. Some example of those attacks is, this is a very poor guy that started to monetize. If you look at the right side of the screen, he said, I built my SaaS with Cursor, 0 handwritten code, very hyped. And then 2 days after, he's been under attack. People have started to find vulnerabilities in his website. They took it down. By the way, if you look up his handle, he's now a recovered sort of like vibe coder. He said, I learned how to write secure application. He built his app from scratch, introducing security. But again, this is a case where if you blindly trust an AI tool to launch full-scale production application, it's the wrong thing to do. This is the example, I think, found by Reversing Labs initially of hallucinated library injection, slop squatting. They found that AI constantly hallucinates the same names of libraries. And these ultimately are opportunities for attackers to inject libraries. Left side vulnerability is actually the GitLab AI assistant, something we at Legit's research team disclosed, but ultimately we've been able to steal the source code through a prompt injection. So the same AI that writes the code and looks at the code for context can also look at the code for instructions. So we've been able to hide an instruction in plain sight in the source code. And the AI, instead of looking at the code and trying to fix it, has read our instruction, our malicious instruction, and started doing funny things like calling out for different websites and sharing information for web forms that we created with secrets or sensitive customer information. And we could create eventually an attack vector where the entire source code is being shared with the attacker. Same thing happened with Microsoft, with a company called Lasso that found that they have been leaking sensitive data that the AI has been trained on. So again, those vibe coding tools have risks in them that some of them could be prevented by hardening techniques that would disallow the agent to reach out to third parties or only to allowed ones. Here is the case that you probably heard about from about a month ago, where an agent deleted a production database. Again, given full control to do deployments or Git operations. Again, agents today are not in a place where they could be trusted to do something without sandboxing them or giving them a safe place to fail. MCP servers, again, when you send information to an MCP server, you don't really know where this information is going to end up. It might call another MCP servers, another MCP servers. And the whole architecture of MCP is something that is extremely negligent of security scopes. So basically, there is an instruction for the AI how to use the tools the MCP exposes and when, but it's in its own discretion. The AI can decide not to use it or decide to use it at certain circumstances. It can decide which data to send. There is a review step, but many people skip it, and ultimately you end up with AI sending information without anybody's governance to an MCP tool that sometimes was developed by some kid and was published into GitHub and might have vulnerabilities by itself or might call another tool. So again, this is a very, very risky architecture for your data if you don't know what's going on there.
So Before we go on, I have a question for you, Lev. So you've gone through those top 10 areas of risk with vibe coding, and you have some really good examples associated with all of those. And of course, all of them should be considered. But if you had to point to the first area that a organization should look at, or
Mhm.
I'm going to give you two, one or two areas you would recommend they start, what would those be?
So where to start?
Risk standpoint. Yep.
Yeah, I think good question. I think it would be good to start with the very basic principle of the code itself. I think I will start with by saying the code, like we used to say about networks, has we have zero trust in the source code, and use that principle to say, okay, um, how are we protecting against that? Like and then the assumption should be is that every code is AI generated. I know that some organizations are asking, can we detect which code has been detected by AI? I don't think ultimately it's going to be a problem. Like every code is going to have some AI involved in its creation. So assume every code is now has some AI that's been part of building it, and also assume zero trust. So what do you do now? Like, so all the practices like code review or static analysis testing or code quality testing, like make sure all of them cover your critical code. And the second assumption I would take is that the AI coding agent is a collaboration tool that doesn't respect data. It is designed to get as much productivity as possible. It would reach out, it would share, it would train on everything possible to do it. So threat model that situation. If there is sensitive data, if your source code is extremely sensitive, if there is sensitive data involved in the process and our developer endpoints, there are ways to limit the scope of that. There are ways to limit from a network perspective, from a hardening perspective, but you have to take this assumption that the tool doesn't respect any data sharing or privacy rules by design today.
Thank you.
Yeah. Here are four steps, like very like in a segue into the topic of what can you do from like a framework perspective. Four steps. One is let's find those Gen AI pipelines, meaning let's find those tools. We assume every code is generated by AI, but let's find what's being used there. Let's get a bill of materials of all the tool sets and the extensions that are being used. Let's automate security. So make sure security is automated against this entire pipeline. Harden the code generator, harden the coding agent, and then shift security to generation. It is very, very effective and very efficient if with very easy steps, you're going to tell the vibe coding agent, just be more secure. It could be as simple as a base instruction that tells him, check the libraries you're putting to make sure they don't have CVs or they're up to date. Or with a very, very low effort, low hanging set of steps, you could make the code generator be aware of security and improve security. It's not perfect, but investing in this activity would eventually provide really, really good results. At the end, I'll show a couple of examples or maybe a demo, and hopefully I'd love to deep dive into that if you're interested and want to deep dive with our technology after this webcast. The second piece we'll go over quicker is the new application architecture. So this is a little bit of switching gears. Like it's not about vibe coding per se. It's more about, okay, we've created an application right now. This application uses AI. This application reaches out to OpenAI, just can user input. And this is a dangerous thing. OWASP actually mapped top 10 for agentic AI and for protocols and actually for LLMs. And I'm happy there's a lot of literature today on the risks of AI applications, although it's still it's still early, but there's starting to be a lot of literature. I wanted to call out like some of the reasons of why there are risks in the architectures. One, and I called it before, AI is unpredictable. If you give it the same prompt, if you tell it would not behave the same way. It's actually stochastic, it's random. It will not create the same output. It might not take the same course of action. It is very unpredictable, even for various reasons. It's the nature of a neural network, but it's also the nature of AI systems that you're relying on. If you're relying on GPT-5, for example, to carry on things, you don't know what's under the hood, and how much compute power you're getting. So you should expect AI to behave in an unpredictable way. The second thing is that every communication with an AI system or between two AI agents is MCP, is prompt. Prompts are easily manipulated. You could manipulate a prompt in a very easy way. The same instructions that, like the input that AI reads for context, could inject very easily malicious instructions. So the whole so prompts are something that's very hard to protect. Like even if you try to put some kind of a proxy and edit the prompt before they're sent, somebody could just put a prompt in French and bypass that. So because it's natural language, it is virtually impossible to start to control what prompt AI is going to be given. So if you're building a chatbot to talk with customers, you can't really rely on making sure only certain English texts are going to get to the prompt. There's always a way around some of those guardrails, so it's very hard to place protections. The quality of AI output is still unreliable today. Like we said, even we looked at code security. It's still something you can't rely for really complex operations. And if you're using a third-party model, there's a lot of models. Hugging Face is full of models. There are many malicious ones. There are many, some that are not trustworthy. So same like the open source problems. When using a third-party model, there are risks associated, very, very similar to open source, with the credibility, the data that's been trained on, and its intent. Actually, I like the work that's been done by BIML, B-I-M-L, to map out risks in AI architectures. And ultimately, they classify all the risks on an AI system. I bucket all the risks into 4 categories. About your architecture, how your system works, about your supply chain, the models you are using. So are they malicious? Are they bad? Third bucket of risk is the communication, the prompts, like what are you doing with the input or the output and the third parties? And 4 is with your data. Now, people that rely on data that it's OpenAI don't need to worry about this because it's been trained, or they just need to understand what data it's been trained on, but it's fact. But if you are training or fine-tuning your own model, there are risks associated with the data you're training, both on just the quality of what you're going to get, but also risks like legal risk on, are you violating someone's copyrights, or could this data be poisoned either by mistake or on purpose and change? So the 4th category is data. Here's an example of a news event for malicious models discovered Hugging Face. So attackers don't wait. Similarly to what they did a few years ago on every one of those major open source repositories, they're doing this the same now on Hugging Face. Some of the models that people want to test are actually malicious. Another example, MCP. Building an MCP, if you're building a server, so you're ultimately building, and I won't get here deep on what the MCP is, but it is equivalent to an API. It's basically an agentic interface. So AI can speak with your application, and you can expose to your capabilities to an AI system. So if I'm building, this is a architectural graph from Legit. If I'm building a billing service, which is an API that people can call from the internet, and now I expose an MCP API, which people can call or agents can call, I basically bypassed my security flow and created a new security flow, which probably might not have authentication or completely bypass every security guardrail that I have and my exposed data. So MCP is just like API security became so important because it's your window to the world. It's the entry point. MCP is another entry point, but its architecture, again, it's focuses on productivity instead of security. There's another example of an architectural flaw in an AI system that right now is creating a lot of security issues. What can you do? So this is a big topic. the three things we see are happening and want to call out are: one, you need to understand your AI bill of materials. What AI components are you using? What's being used? And to be in control of those AI software. The second thing is perform what's called AI security testing, static analysis, but for AI software. Can you test software architecture for specific risks? And I can actually demo some examples of that. And the third thing is be better and start practicing threat modeling AI systems. There is information about how to do this, how to build controls, but threat modeling AI system is a skill every organization needs to do. It needs to understand how can we guardrail those systems that do things that we can control. How can we at least protect against against prompt injection in a reasonable way. I'll pause here for a quick second, and I'll show you a very, very brief demo of things that we do at Legit.
Can I hit you with a question from the audience while you're doing that?
Absolutely.
Feels like good timing. So the question is, we have SAST scanners in place now.
Okay.
Can we use that to help solve the problems that you just spoke to?
So I would say most likely not. So like again, vibe coding, these SaaS tools basically just scan code. They're unaware of AI generating tools that can help you harden or secure code assistance. Finding risky AI situations, some of them start to do this. I haven't seen them doing this, but some of them started to identify some of the risks in AI systems, but it's still something that most of them are still not looking at. They're focusing on traditional code problems. And the thirdly, I would say, not very, very few of the SaaS tools today can scan during generation. They can scan the code as it's being generated. Usually it's a tool that runs after the fact. It's slow. It runs when a pull request happens, or most organizations runs periodically, nightly after a big build or a big release. So again, it's very unlikely that the tool is helping with these.
Okay, thank you so much.
Yeah. So very, very briefly on the Legit system. Legit is an ASPM tool designed to help you basically supercharge your AppSec program. It helps you get all the risk into one place, aggregate it, prioritize and fix it, and also protect your entire supply chain. So you can see here, we've prioritized from 17,000 findings into only 300 that are now things that we absolutely need to fix through a lot of prioritization techniques and risk scoring. The actual thing I want to focus on is specifically AI. So one of the things that Legit is doing as Legit is connecting to the environment is basically inventorying everything in the environment. So things like all the software components, the application assets, etc. And then some of them are actually the AI components, so AI models or things like MCP servers. So for example, here are all the different AI models. I'm using here 65 different models in various labels, level of downloaded, different licenses. If I want to see also my MCP server, so here are 3 projects that my actual engineers have built. These projects expose tools, they use resources, they have prompts that they expose outside. So here you can see the actual prompt that's being given in this MCP server. What's nice about Legit is that it's not just scanning, it tells you when things changed. So we have a change log where basically we can see every time a new GenAI model was added, for example. So on November, in this log, somebody have added the new GenAI model into their application. They're using OpenAI to import a new model. Same thing for MCP. If somebody is now creating a new MCP server, this is an event we capture and we can report on. You can get events and alerts every time new change happens, a new AI system is introduced, and be in control of what's happening. It's also possible through Legit to build governance flows where if the model is not approved, then we would like to block, or we would like to alert the developer that this is not an approved model through basically just labeling. The other example I want to show relating to AI governance is looking at AI-specific risks. So I'm looking at the entire set of findings across my environment. We've introduced a new finding type called AI risks. This shows different AI risks that we're able to find. Things like prompt injection, insecure output handling, using AI model with low reputation, etc. So there are various policies. Here I've got 7 different findings across my environment for project insecurely using AI components. As we move forward, we're adding more and more and more policies, looking at these top 10s that we have had and OWASP to detect more and more risks in various applications, help fix them, and also help move them to the context of developers. So this finding, although it appears in our platform, can alert the developer as they write code and directly into their IDE. So when you run legit on your applications, within minutes, you get discovery of all your AI models, your MCP servers, your third parties, and also you get information about all the different risks associated with your AI. The last example I want to show you is launch one of our vibe coding environment, is that we can, as we inventory users, for example, we can see exactly which ones are utilizing AI coders. So for example, here I can look at the users that are using Coding Assistant. In this case, we're in an environment where we have Copilot, so the users that are utilizing Copilot from GitHub. What it lets us do is actually find those AI-generated pipelines. So we can go and I'll show you actually a visual example where we can go to our, for example, legit query engine, and then search for, in this case, all the repositories which are accessible by those users that are using coding assistants. So it will show me every repository that's subject to vibe coding. And then I could also use Legit's database to see the ones that don't have control of type code review. I'm sorry for doing this quickly, but ultimately my query was, show me all the repositories getting AI-generated code and the ones that actually are lacking code review. There's 69 of them that actually no human is looking for review. Can actually look at the ones that are lacking DAS scan or lacking SAS scan or are missing some of those scanners. I can save this as a policy in Legit and start having these pipelines either blocked or alert and make sure I have complete coverage of where this situation is happening. So Legit helps you threat hunt for any policy. I've just used a very, very deep example where you can find violations where specific situations are violating policy. Same things on the other side. If I'm looking at all my code repositories, I can hunt for the ones that are, for example, using an AI model, and then also, together with that, handle sensitive data. So using our engine, I've been able to find, I have one project in my environment that, looking at this context, sort of like business card, this project is using AI, Hugging Face, it's touching with OpenAI, and it's handling PII. This is an automated analysis that happens in minutes that helps you pinpoint the specific applications. So now I can go and enforce the policies I want or ensure that all the guardrails exist. So I'll stop sharing here. I think we're also nearing the end of the presentation.
Yeah, we had another question, Leon. I thought I'll paraphrase it, but it seems to fall well with the conversation we're just having. But basically, the question is, this person's spoken with peers in other organizations where there's an attempt to put limitations on AI usage and constraints and guardrails. Is this practical, or is the genie out of the bottle?
I don't think it's practical to stop developers using AI to write code. They'll find ways. If you block it on their endpoint, they'll create a container and build on the container. So it's a fact. Everybody's going to use it. What is possible is to control their options and to say, you're only going to use this tool, and we have learned how to use this tool safely. So it is possible to give them the way to do, but it's not possible to limit. I don't think it makes sense to limit. There are a lot of like AI skeptic organizations that are afraid of adopting this technology because of various reasons. They should assume it's happening without their knowing it.
Thank you for that.
Yeah. So just to sum up in 1 minute, we talked about AI writes code, we talked about AI creates new architecture, and AI enables secure coding. What I wanted to take away is that AI creates a lot of risks, but it's also the solution. Each one of the solutions we talked about, like generating security into the code generation step, leverages AI. Basically, you train AI to be more secure. AI can help you solve a lot of the problems. We had a separate webcast, and probably a lot of the content we didn't share here is how you use AI to do better AppSec, which is a complete topic where you could actually fix things using AI. But to recap, AI code generation is risky. It's an untrusted output, and the tool itself is dangerous. You don't know what's going to do, at least in terms of data protection. What you need to do are two things. You need to make sure there's security guardrails on that generated code, and you need to harden that agent. You need to put on a seatbelt for your developers that write code. The second topic we talked about is about AI security testing, is about how to secure the AI that is part of the applications. We talked about visibility and governance. Let's discover the AI systems, the models, what we're building, performing testing and threat modeling. These things sit at the heart of both secure development and the changes that are happening that I mentioned before about like this new AI native pipelines in a new era, and are also at the heart of what we at Legit Security are doing. So if you're interested and you liked a quick demo that we did, feel free to visit our website and reach us out. Dave, let me know if there's any other question or anything you want to add.
No, thank you for taking the time, Liav, and thank you to everyone who joined us. I think the whole notion of the fact that these agents are actually higher risk developers is really interesting, and this zero trust for code concept is really key as well. I would just encourage anyone who wants more information, visit our website, legitsecurity.com. We have some great content, blogs, white papers, etc., on the topic, and we'll certainly be having more webcasts on AI and the impact on development in the future. So thank you all and have a great rest of your day.
Thank you.